Hello everyone. So we have gotten a good question from the chapter of chemical kinetics. Chemical kinetics is an easy chapter, and I think one should target this particular chapter, because usually questions from this particular chapter are pretty easy in both mains and advanced. So, anyways, let's begin. So we have got a first order reaction which looks something like this. A reactant A, it becomes product B. Okay. And all the details about it have been given, like activation energy 70 kilojoules, and initially a 20% solution of A was kept at 25 degrees Celsius for 20 minutes and 25% decomposition took place. Okay, so let's write all the values one by one. Okay, so 20% solution of A, I assume that it means concentration, so let me just write 0.2x over here and 0. Okay, and you can see that 25% decomposition took place after 20 minutes. Okay, which means after 20 minutes, 75% of this solution is left. Okay, so since this is a first order reaction, we can find the value of rate constant very easily, right? Which is basically equal to 1 by T natural log of A naught by A, where A naught is the initial concentration of A and A is, the present concentration of A. Okay, so let's put all the values. It will be, the reaction has been going on for 20 minutes, and into 60 seconds we will try to do all the questions in SI unit only, and this one will be 0.2x divided by 0.2x into 75 by 100, right? Okay, so once we use a calculator, we will find that this value is equal to 2.33 into 10 to the power minus 4 per second. Okay, that is the value of rate constant. Okay, now let's see what we have to find. What will be the percentage decomposition in the same time in a 30% solution? So we have been asked to find the alpha, the percentage decomposition at 30% in the 30% solution at 40 degrees Celsius. Okay, so the temperature has been changed this time round. So yeah, let's do one thing. Let's try to find the rate constant at 40 degrees Celsius. Okay, and for that we will use this particular formula. Okay, because this rate constant, it is constant at all temperatures, right? Yeah. Okay, so this will be equal to, yeah, K25 by K40, where K25 means rate constant at 25 degrees Celsius. This will be EA divided by R into 1 by T40 minus 1 by T25. Now I wrote it this way because I have to convert this into Kelvin, right? 40 is not what we are going to write here. So this will be ln 2.33 to 10 to the power minus 4 by K40, which is equal to the activation energy 70 kilojoule. So when we convert that to joule, this is what we will get. Okay, let's do one thing. Let's convert this natural log to log, because that is easier to calculate, I feel. So this one will become 19.14. Now after we multiply 2.303 with 8.14, this is what we get, and this will become 1 by 273 plus 40 is 313 minus 1 by 298, right? Okay, so this is what we get. 2.33 to 10 to the power minus 4 divided by K40, that is equal to 70,000 by 19.14 into this entire thing. It will become minus 0.00016. Okay, and I have used a calculator, but please don't use a calculator when you're doing such kinds of sums, because not using a calculator will help you practice for the main exam. From here we can calculate K40, which is equal to, roughly equal to, 8.8 into 10 to the power minus 4 second inverse. Okay, all right. So now we have to find the percentage which has decomposed when 30% solution is taken, right? So let's write another equation. A to B, initially there is 0.3x 0. Okay, and let me just check after how much time. In the same time. Okay, same time means 20 minutes. Yeah, 20 minutes. So let's just put the values. Like I said, this is a totally formula based kind of uh, chapter. You just have got several formulas which you have to apply at the right time. Okay, and you have to remember these formulas as well. That is very important. 0.3x into 1 minus alpha, right? I mean, it's quite obvious, right? After 20 minutes this will be 0.3x 1 minus alpha, and over here 0.3x alpha will be formed, right? Okay, so yeah, let's cancel the x. The most of the terms will be cancelled here, and time is equal to 20, right? Time is equal to 20 into 60 actually, because we will be doing that in seconds. Okay, so from here we can calculate alpha. um, we can calculate 1 by 1 minus alpha to be equal to 2.87. Therefore alpha will be equal to 0.65, roughly equal to 0.65, which means that 65% of the 30% solution has decomposed. All right, has decomposed. So yeah, that is it from this sum. Just try to remember all the formulas and try to apply them at the right time, the right place as well. Okay, and do remember the units for each and every like for example, for a first order reaction, the unit of rate constant is per second, second inverse, right? So try to remember these, and yeah, that's it. Thank you.